Alright guys, so tonight we're going to look at parts of a parabola. Basically, this is because we are not really identifying what these are when we see a parabola. What is the axis of symmetry? What is the vertex? How do I use the quadratic formula? What are zeros of a polynomial? What are x-intercepts? And how do I find the y-intercept? These are all things that we're struggling with. And therefore, we are going to revisit what parts of a parabola are. So first up, we're going to do is our vertex. So our vertex is also known as the turning point of a parabola. Now, in case we're forgetting what a parabola is that is when the general form ax squared plus bx plus c, a parabola is that beautiful U shape that we get in our graph. And the vertex is the turning point of that, also known as the vertex. So this is my vertex. This is where I turn, and this has the value of x comma y. We're going to talk about this in a little bit. How do I find that, and what does that look like? And we're actually going to do that with axis of symmetry. So this is why they are on the same slide. We have vertex is the turning point of a parabola, but how do I find that turning point? And the way that we find that turning point is using the axis of symmetry. Now the axis of symmetry is actually pretty easy to find. When I have the formula ax squared plus bx plus c, I take the opposite of my b value and I divide it by 2 times my a value. Remember that a and that b come from here. Make sure you take the sign of a and b into your axis of symmetry. So this is the formula for the axis of symmetry. The axis of symmetry is by this formula here, opposite of b over 2a, which is our formula. But what is the axis of symmetry? The axis of symmetry is a vertical line where x equals the opposite of b over 2a that cuts the parabola in half. Okay, so the axis of symmetry is a vertical line where x equals negative b over 2a that cuts the parabola in half. And you can kind of think of this as a reflection. Okay, so if you have questions, please make sure to write them down, and that way we can address them tomorrow. Next we have is the x-intercepts. The x-intercept is where my graph or my parabola cuts through the x-axis. So points where the graph intersects points where the graph intersects the x-axis. So if we are looking at a graph like this, let's say this is our x-axis, and our parabola somehow looks like this. We have some value and some value, x sub 1, let's call it, and x sub 2. These are my two intersections or x-intercepts of that graph. What's cool about this is the x-intercepts are also known as the zeros of a polynomial, because when we're talking about the zeros of a polynomial, this is where the function ax squared plus bx plus c is set equal to 0. Okay. Now since it's set equal to 0, we can then find the zeros of the polynomial, also known as roots. So there are a couple different ways. We can either say x-intercepts, we can say zeros of a polynomial, or we can say roots. All of these things mean the same exact thing. All of them mean our x-intercepts. So if we're looking for the zeros, we're really just looking for x sub 1 and x sub 2 because remember, our degree or the highest power tells us how many real solutions we will have, up to how many real solutions we will have. So sometimes, and we're going to see this next week, when we have unreal solutions. So the problem may ask you to find the real solutions or identify all the real roots, or it could say find all solutions to satisfy the polynomial. And in that case, we might get some imaginary numbers. Let's talk about the quadratic formula. Now, a lot of students just remember it as the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And again, that is x equals, because we are trying to find when ax squared plus bx plus c is set equal to 0, we are trying to find the zeros of the polynomial. I'd like to take a look at this and just break this up a little bit. Notice here, we already talked about the axis of symmetry. What we really have is x is equal to the axis of symmetry plus or minus the distance away to intersect the polynomial. This is really what this says. So my axis of symmetry, we already talked about on the previous slide that it's the opposite of b over 2a. Well, if this is where we'll just AOS, we'll call this axis of symmetry. If this is my axis of symmetry, we're going to move in the right direction some distance, and that distance is given by b squared minus 4ac all over 2a. And we're also going to the left some distance, so we put a minus, and that's what this plus or minus actually means. We're going to go to the right some distance, we're going to go to the left some distance. So if we look at this graphically, when we have a parabola and we have some axis of symmetry, this is x is equal to the opposite of b over 2a. That's always how this is given. Let's say our x-axis runs through like this. Let's call this the x-axis. Well, what's nice about this is on this side we have, from our axis of symmetry, we have plus the square root of b squared minus 4ac all over 2a. And on the opposite side, we have minus the square root of b squared minus 4ac all over 2a. So we have some distance that we're going to add, and this will give me what we've been calling x sub 2, and some distance that we're going to subtract, and that'll give me x sub 1. Now, this does no way mean that our value is negative or positive. Sometimes they'll both be negative, sometimes they'll both be positive, and sometimes it'll be one of each. It really just depends on what our graph looks like. The same holds true if we have a negative function. When we use the quadratic formula, all that'll happen is our parabola will simply turn over, will simply shift and face downward. Now obviously that didn't shift correctly, but really our parabola, the whole thing holds true, that we are going to have some value that's going to be to the right and some value that's going to be to the left. So some value to the right, some value to the left. Our axis of symmetry is still going to be the opposite of b over 2a. I know that got a little funky. That's okay. So we'll just put it back. And really, so that's really what our quadratic formula looks like. Okay, so now how about applying the quadratic to find the y-intercept? Now, we found that our axis of symmetry, let me get my pen here, my axis of symmetry is x equals the opposite of b over 2a. Well, if we want to find our vertex, we need some y value. Remember, we talked about earlier that it's x comma y. So the vertex function is actually given like this. The opposite of b over 2a, that's my x value, and then the function when evaluated for that value. Okay, that might have gotten lost. So let's talk about this again. This is my axis of symmetry. And this is when I take the value of my axis of symmetry, value of axis of symmetry, and substitute it into the original ax squared plus bx plus c. So that might seem a little confusing. So let's take all of this, let's shrink it up and see what we mean with an actual example. The vertex is actually one of the easiest things to find, and I always find that students struggle to find the value of the vertex, but it's actually pretty simple. So let's just take any quadratic. Let's say x squared minus 6x plus 8 equals 0. Now this is factorable, right? I'm looking for factors of 8 that add to give me negative 6. But we don't really care about factoring it that way. We're going to take the opposite of b over 2a to find out what our x value is. So we're going to have the opposite. My b term is always in this, my x term, so negative 6 over 2 times my a. There's nothing there, so we assume that it is a 1. Negative 6 is 6 over 2, and that will give me 3. So now that we've found the axis of symmetry, what we're going to do is we're going to take this value and we're going to substitute it back into the original. So we're going to have 3 squared minus 6x, but remember x is 3, plus 8. So 3 squared is 9, minus 3 times 6 is going to give me 18, plus 8. So 9 minus 18 is going to give me negative 9 plus 8, and so the value is negative 1. So for our vertex, remember we just took the opposite of b over 2a and then substituted it back into our function. We get that our vertex, or our turning point of the parabola, is 3 comma negative 1. That's it.
You have just been witness to a Miss LaTorre Mathematics event.